Several decades ago, technicians working with large radio antennas noticed a faint, steady noise during routine calibration. The antennas were aimed at empty regions of the sky, far away from known stars and galaxies. There were no storms. There were no nearby radio towers. The equipment was clean. Still, the whisper of static remained. At first, it looked like a technical problem. Cables were replaced, metal parts were scrubbed, even bird nests inside the antenna were removed. The signal did not weaken, it did not disappear. It stayed gentle and evenly spread. The strange part was its repetition. Different laboratories, different countries, and different instruments reported the same quiet background. No matter where the antenna pointed, the same soft pattern filled the data. The noise did not come from a single direction. It covered the entire sky. This behavior was difficult to explain using familiar sources. Normal radio signals come from specific objects, like planets, stars, or human technology. This signal did not act that way. Instead, it behaved like a faint fog of energy, filling all of space. Later, scientists found a critical hint. The uniform temperature of this signal matched what physics predicted for a universe that was once extremely hot and dense, and then expanded and cooled to approximately 2.7 Kelvin. This was not sound in the everyday sense. It was radiation, meaning energy traveling as waves. Radiation is like sunlight or heat from a warm cup of tea, but at a much lower energy level. In everyday life, a similar effect happens in a quiet room late at night. Even when appliances are turned off, a faint electrical hum can sometimes be heard. That hum is not from a single device, but from the environment itself. In space, this background signal works the same way. It is not coming from one place. It is part of the environment of the universe. This ancient signal was not produced by stars or galaxies. It came from a time before they existed, when matter and energy were packed tightly together. As the universe expanded, that intense energy cooled and stretched into long, gentle microwave waves. Microwaves are a type of invisible light, similar in family to the waves used in kitchen microwave ovens, but far weaker. This was the moment when the phenomenon gained its scientific name and place in cosmology. It became known as the cosmic microwave background, a quiet, permanent echo of the early universe that still fills all of space today. The first clear recognition of this ancient signal did not come from a planned discovery. Instead, it emerged by accident in the mid-1960s, when two engineers were testing a large, horn-shaped radio antenna designed for satellite communication. They expected silence from empty space. Instead, they kept receiving a soft, uniform background noise. The sound was not loud. It was not sharp. It was constant, like a steady hush that could not be switched off. At the time, most scientists believed that space between galaxies was truly empty. Light came from stars. Radio waves came from specific cosmic objects. This result did not fit those expectations. The signal did not move. It did not flicker. It stayed evenly spread across the sky. At first, it looked like a technical problem. Cables were replaced, metal parts were scrubbed. Even bird nests inside the antenna were removed. The signal did not weaken. It did not disappear. It stayed gentle and evenly spread. The structure of the experiment was simple. A large metal antenna collected radio waves from the sky. However, the natural phenomenon behind the signal was not simple at all. What they were measuring was radiation that had been traveling through space for billions of years. Later, scientists found a critical hint. The uniform temperature of this signal matched what physics predicted for a universe that was once extremely hot and dense, and then expanded and cooled to approximately 2.7 Kelvin. This was not sound in the everyday sense. It was radiation, meaning energy traveling as waves. In everyday life, this is similar to turning on an old radio and hearing static even when no station is tuned in. That static feels meaningless at first. Yet, in reality, it is full of patterns created by real physical processes. The engineers experienced the same kind of realization when the static refused to disappear. This ancient signal was not produced by stars or galaxies. It came from a time before they existed, when matter and energy were packed tightly together. As the universe expanded, that intense energy cooled and stretched into long, gentle microwave waves. Microwaves are a type of invisible light, similar in family to the waves used in kitchen microwave ovens, but far weaker. Historically, this discovery changed cosmology. Before this moment, several competing ideas about the origin of the universe existed. After it, one idea became strongly supported, that the universe had started from a hot, dense state and expanded over time. Eventually, this signal received its formal scientific identity. It was named the cosmic microwave background, and it became one of the strongest pieces of evidence for the modern understanding of the early universe that still fills all of space today. This ancient light has survived because of how the universe itself changed over time. In the earliest moments, space was filled with extremely hot plasma, a state of matter where electrons were not attached to atoms. Light could not travel freely. It bounced constantly between charged particles. As the universe expanded, everything slowly cooled. Expansion in physics means space itself stretches, like the surface of an inflating balloon. When the temperature dropped enough, electrons began to attach to atomic nuclei. This process is called recombination, which means free particles combine to form stable atoms. Once this happened, light no longer became trapped. It began to move freely through space. That escaping light is the same light that is still present today. It did not disappear. It did not fade out. It simply kept traveling while the universe kept expanding. Over billions of years, the stretching of space stretched the light as well. Short, energetic waves slowly became longer, weaker microwave waves. A simple, everyday example helps explain this. When a siren passes by, the sound changes pitch. A moving source stretches or compresses the sound waves. Something similar happens to light in an expanding universe. But instead of motion through space, the space itself stretches. This effect is called redshift, which means light waves become longer and lose energy. This survival of the signal is not about power. It is about persistence. Space has no walls to absorb it and no medium to block it. Empty space allows radiation to travel almost forever. That is why this light from the early universe still exists, even after billions of years. This phenomenon connects structure, natural law, and cosmic scale. The structure was the early hot plasma. The natural process was expansion and cooling. The cosmic scale was the entire universe growing in size. Together, they allowed a simple form of energy to become a permanent background that still surrounds everything. Today, this signal is extremely weak. It is colder than natural darkness and quieter than most electronic noise. Yet it remains one of the most reliable records of the universe's earliest physical conditions, preserved not by memory, but by the constant movement of light through expanding space. Scientists did not immediately understand how old this faint signal was. At first, it was only recognized as unusual background noise. Age is not something that can be seen directly in space. It must be inferred by comparing patterns, temperatures, and physical behavior. The structure of the analysis relied on measuring temperature. This signal had a very precise temperature, just a few degrees above absolute zero. Absolute zero is the lowest possible temperature, where atoms barely move. Ordinary stars produce much hotter radiation. Even cold interstellar dust is warmer than this signal. That difference became an important clue. Natural physics provided the next step. A universe filled with stars would produce uneven, directional radiation. This signal was smooth and came from all directions equally. That type of uniformity matches a state where the universe itself was the source, not individual objects. Historically, this realization emerged through careful comparison. Scientists compared the signal to theoretical models created years earlier. These models predicted that if the universe began in a hot, dense state, it would leave behind a uniform glow after cooling. When the measured temperature matched these predictions, the age relationship became clear. The signal had to be older than any star, older than any galaxy. An everyday comparison helps make this clearer. Warm pavement after sunset can stay warm longer than the air because it absorbed heat earlier in the day. The warmth does not come from the present sun. It comes from stored energy in the past. In the same way, this signal carries stored energy from the earliest time of the universe, not from later cosmic objects. This understanding filled a major gap in cosmology. It connected structure, observation, and natural law. The signal was not a local effect. It was a fossil of a time when stars did not yet exist. By recognizing its temperature, uniformity, and predicted behavior, scientists understood that this faint background was the oldest light ever observed, older than every visible object in the night sky. The idea that the universe was once hot and dense is not based on imagination. It comes from direct physical evidence carried by this background radiation. The structure of this evidence lies in temperature, uniformity, and spectrum, which means how energy is distributed across different wavelengths of light. When scientists studied this signal in detail, they found it matched what is known as a perfect blackbody spectrum. A blackbody is an object that absorbs and emits energy in a very predictable way based only on its temperature. Heated metal, warm skin, and even a cup of hot water all glow an invisible infrared light because of this same rule. The background signal followed these rules with extreme precision. Natural phenomena never create such a perfect pattern by accident. Stars have irregular surfaces, galaxies have uneven structures, dust clouds block and scatter light. This signal showed none of that. It behaved as if it came from a time when the entire universe itself acted like a single, hot object. The history of this realization connects laboratory physics to cosmic science. Physicists had studied blackbody radiation in controlled experiments long before this signal was measured. When the cosmic data matched the laboratory curves, the conclusion became unavoidable. The universe must have once been compressed into a much hotter, denser state. A simple, everyday comparison can be seen in a kitchen oven. When the oven is turned on, the air and walls slowly fill with heat until the temperature becomes uniform. That even warmth does not come from one spot. It comes from the entire space being heated together. The early universe behaved in a similar way, except the space itself contained the heat. This connection between structure and natural law formed one of the strongest foundations of modern cosmology. The background signal was not just noise. It was physical proof that the entire universe once shared the same high-energy conditions before expanding and cooling. On the scale of billions of light years, this faint radiation still carries that message. It proves that the universe did not begin cold and empty, but started in a state of extreme heat and density, leaving behind a quiet, permanent thermal fingerprint. By the time this background radiation took its current form, the universe had already begun to cool dramatically. In the earliest phase, energy existed as intense, high-frequency radiation. As space expanded, that energy had no container to hold it steady. The structure of space itself stretched, and the radiation stretched with it. This stretching process changed the nature of the light. Highly energetic gamma and X-ray radiation slowly shifted into visible light, then into infrared, and eventually into microwaves. This process is called wavelength stretching, which means the distance between the peaks of the wave becomes longer over time. Longer waves carry less energy and feel colder in physical terms. This is why the ancient light is now called frozen in a scientific sense. It is not literally ice. It is energy that cooled because the universe expanded. In nature, cooling often happens through contact with colder surroundings. In space, cooling happens because the space itself grows larger and energy spreads thinner. A simple everyday comparison exists in a hot cup of coffee left on a table. At first, steam rises quickly. The liquid is full of motion. Over time, the heat spreads into the room. The coffee becomes calm and lukewarm. The energy does not disappear. It spreads out and becomes gentle. The universe behaved in the same way, but across unimaginable distances. Historically, scientists confirm this by measuring the precise temperature of the background radiation. It matched what theoretical physics predicted for light that had been stretched by billions of years of expansion. The temperature did not match any modern heat source. It matched a cooling history. The natural phenomenon here connects structure and time. The structure was dense, hot radiation. The natural law was expansion and energy conservation. The result was a universe filled with extremely cold microwave light. On a cosmic scale, this frozen light fills every direction. It is not trapped in one area. It is carried everywhere because it is part of space itself. It is quiet, cold, and persistent, acting as a permanent thermal shadow of the universe's earliest hot state. The background radiation that fills space has a very specific temperature. It is close to absolute zero, but not exactly at it. This small difference matters. Absolute zero is the lowest possible temperature, where atomic motion nearly stops. The cosmic background sits just above this point, creating a stable and measurable thermal state across the universe. The structure of this phenomenon is grounded in thermodynamics, the study of heat and energy. Every object that has a temperature emits radiation. Warmer objects emit stronger and shorter waves. Colder objects emit weaker and longer waves. The cosmic background follows this rule perfectly, behaving like an object that is almost completely frozen, but not entirely. This temperature is not random. It reflects the balance between the original heat of the early universe and the cooling effect of expansion. Natural physics forced the energy to spread as space grew. The result is a quiet thermal field that fills all of space equally. A clear, everyday example is found in a dark room with no open windows. After heaters and air conditioners are turned off, the temperature of the room slowly becomes uniform. No corner stays hotter forever. No wall stays colder forever. The room reaches a quiet balance. Space experienced a similar process, but on a universal scale. Historically, this precise temperature was one of the strongest confirmations that the signal was truly ancient. Instruments designed to measure heat with extreme accuracy found the same value again and again. It did not change over seasons, years, or locations. That consistency gave scientists confidence that they were measuring something fundamental. This phenomenon connects physical structure, natural law, and scale. The structure is a sea of invisible radiation. The law is the predictable behavior of heat. The scale stretches across the entire observable universe. Even though this temperature is extremely low, it is not meaningless. It represents the leftover warmth of creation itself, evenly distributed, stable, and permanently woven into the fabric of space. Although the cosmic background appears smooth and uniform, it is not perfectly even. Tiny differences in temperature exist across the sky. These differences are extremely small, often measured in millions of a degree. Yet, they are among the most important patterns in cosmology. The structure of these variations is linked to density. In the early universe, matter was not distributed perfectly evenly. Some regions were slightly denser, while others were slightly emptier. Where matter was denser, gravity was slightly stronger. This affected how energy moved through space and left faint temperature marks in the background radiation. This natural phenomenon follows simple physics. Stronger gravity pulls more tightly on energy, slowing it down slightly. Weaker gravity allows energy to move a little more freely. These small changes created the temperature ripples now seen in the background radiation. An everyday example appears on the surface of a calm lake. From far away, the water looks flat. Up close, tiny ripples can always be found. The lake is not perfectly still, even on a quiet day. The background radiation behaves in a similar way. It looks smooth, but gentle variations are always present. Historically, satellites such as COBE, WEMAP, and Planck were built to measure these tiny differences. They mapped the sky with incredible precision and confirmed that the ripples were real. They were not caused by instruments. They were built into the structure of space itself. These small temperature differences became the seeds of large structures. Regions that were slightly denser attracted more matter over time. Those regions slowly grew into galaxies, clusters, and large-scale cosmic filaments. On a cosmic scale, these tiny ripples determined the shape of everything. A difference so small that it cannot be felt by any human instrument without extreme precision eventually controlled the placement of stars, galaxies, and planetary systems. Space eventually stopped behaving like an empty stage and began to act like an active carrier of information. The structure of the universe itself turned into a medium that could hold and transmit energy without wires, air, or material contact. In the early universe, energy was trapped by charged particles. Once neutral atoms formed, space became transparent. From that moment, space did not just contain radiation, it carried it freely. This natural process transformed the universe into a silent transmission system that has never been turned off. This works because electromagnetic radiation does not need air or solid matter to travel. Light from the sun reaches Earth through the vacuum of space. Heat from a distant star travels the same way. The background radiation uses the same physical rule. The structure of space allowed it to move endlessly. A simple everyday comparison exists in wireless signals. A phone can receive music without wires. There is nothing visible between the phone and the signal source. The air looks empty, but information is moving through it. Space behaves in a similar way, except the medium is the fabric of the universe itself rather than the air in a room. Historically, this idea shifted how scientists understood emptiness. Empty space was once considered passive and inactive. After studying this background radiation, it became clear that space could carry energy constantly, even when no stars or galaxies were nearby. This natural phenomenon ties together structure and scale. The structure is space-time itself. The natural law is the behavior of electromagnetic waves. The cosmic scale is the entire observable universe, acting as a continuous transmitter. This silent transmission does not come from a machine. It does not have an origin point that can be touched. It is built into the way the universe expanded and cooled, making space itself a permanent messenger of the earliest physical conditions. The oldest light in the universe carries hidden patterns that reveal the shape of space itself. These patterns are not written as words. They appear as subtle variations in temperature and polarization, which means the direction in which light waves vibrate. The structure of this phenomenon is geometric. When the early universe released this radiation, it traveled through space-time that was not perfectly simple. Space had curvature and structure influenced by gravity and the distribution of matter. As the light moved through these regions, it carried imprints of that geometry. Natural physics explains this through gravitational influence. Gravity bends the path of light very slightly. Dense regions create tiny distortions. Empty regions allowed more direct travel. These effects were preserved in the background radiation as faint geometric signatures. An everyday comparison can be seen in a patent glass window. Light passing through smooth glass travels cleanly and evenly. Light passing through textured glass picks up shapes and distortions. Space acted like that textured glass for the oldest light, adding structure without destroying the signal. Historically, scientists analyzed these patterns using detailed sky surveys. By studying the angles and spacing of temperature variations, they could calculate whether the universe is flat, curved, or shaped in more complex ways. The results showed that the overall geometry of the observable universe is very close to flat. This ties structure to natural law and cosmic scale. The structure exists in the way space-time itself is shaped. The natural law comes from gravity and the behavior of light. The scale reaches across the entire observable universe. The oldest light does not just tell a story about temperature, it carries a silent map of the universe's structure, encoded in patterns too precise to be random and too consistent to be. This ancient background of radiation is not far away. It is not located only in deep space. It is passing through the Earth and through living bodies at every moment. This happens because the radiation fills all of space evenly, including the region where the planet exists. The structure of this phenomenon is based on the weak but constant presence of electromagnetic waves. These waves do not carry enough energy to cause harm or create heat that can be felt. They exist as a silent field that moves at the speed of light and does not stop when it encounters ordinary matter. In natural physics, most waves can be blocked. Sound is blocked by walls. Light is blocked by solid objects. This background radiation behaves differently. Its wavelength and energy level allow it to pass through atoms with almost no interaction. Atoms are mostly empty space, with a tiny nucleus and distant electrons. Because of this structure, very weak radiation can move through the body without being noticed. A familiar example exists in everyday medical imaging. X-rays can pass through skin and muscle but are blocked by bone. Wi-Fi signals pass through walls to reach phones in different rooms. Radio signals travel through buildings to reach car antennas in underground parking areas. In a similar way, this ancient radiation passes through the body without being felt or detected by senses. Historically, this realization came after scientists began measuring the background signal from satellites and high-altitude balloons. These instruments showed that the signal was not blocked by the atmosphere. It came from every direction, including straight down through the planet and straight up from outer space. This means that the signal does not travel around the Earth. It passes directly through it. The planet does not shield against it. Mountains do not block it. Oceans do not absorb it in a meaningful way. The radiation remains present everywhere, at all times. This connects natural structure to human existence. The structure is the transparent nature of atoms. The natural law is the behavior of low-energy electromagnetic waves. The human scale is the body, skin, and internal organs, all existing inside this invisible field. The radiation does not leave marks. It does not produce sensation. It does not create memory. Yet it continuously passes through skin, muscle, bone, and tissue. It existed before the Earth formed, before life began, and before human civilization appeared. On a cosmic scale, every living organism exists inside this ancient signal. Life evolved while it was already present. Bones formed, cells divided, and nervous systems developed while this radiation moved through space without interruption. The body does not notice it, but the body has never been outside of it. This makes the signal not just a distant object of study. It is part of the present physical environment of all biological life, a quiet and permanent cosmic background that flows through every living thing without pause. The background radiation did not only survive in space, it actively shaped where stars and galaxies could form. In the earliest universe, matter did not naturally gather into neat structures. It needed small guides, and those guides came from tiny irregularities preserved inside this ancient radiation. The structure behind this process begins with density. Some regions of the early universe were slightly denser than others. These differences were extremely small, but gravity responds to even the smallest imbalance. Where density was slightly higher, gravity pulled more strongly. Where density was slightly lower, gravity pulled more weakly. Natural physics then took control. Gas and dust were slowly dragged toward denser regions. Over long periods of time, these regions grew heavier and more compact. The subtle temperature variations in the background radiation acted like invisible fingerprints of these density differences, marking where structure could grow. A simple, everyday example can be seen in falling snow. When snow falls on flat ground, it looks even from a distance. Over time, small bumps cause more snow to gather in specific areas. Tiny differences slowly become visible piles. In the same way, tiny differences in the early universe slowly turned into massive structures. Historically, scientists confirmed this connection by comparing detailed maps of the background radiation with maps of galaxy distribution. The patterns matched. Regions with slightly warmer or cooler background temperatures aligned with later galaxy clusters. This was not coincidence. It was a physical cause and effect chain stretching across billions of years. This phenomenon connects structure, natural law, and cosmic scale. The structure was microscopic temperature variation. The natural law was gravity acting on mass. The scale reached from tiny quantum differences to galaxy clusters that span millions of light years. Without this ancient signal, the universe would not have developed the same complexity. Gas might have stayed too evenly spread. Gravity would have lacked guide. Galaxies may have formed more slowly or with less order. Stars formed by collecting hydrogen gas into dense, hot cores. Planets formed from leftover dust orbiting those stars. All of that required starting points. The background radiation quietly provided those starting conditions before any star existed. On the scale of human history, this influence is invisible. On the scale of cosmic history, it was essential. The background radiation was not only a passive echo of the beginning, it became an invisible architect, shaping the locations where cosmic structures would later emerge across the universe. The Milky Way did not appear randomly in space. Its position and broad structure were influenced by invisible patterns that existed long before the first stars ignited. Those patterns were carried by tiny temperature differences in the background radiation that filled the early universe. The structure behind this begins with gravitational potential, which means the ability of a region to attract matter due to its mass. Slightly colder regions in the background radiation represented slightly denser zones in the early universe. Warmer regions represented slightly less dense zones. These contrasts were small, but gravity is patient and works over long periods. Natural physics explains this through attraction. Gas naturally moves toward regions of stronger gravity. Over millions of years, hydrogen and helium gases slowly drifted toward denser zones. These movements were not violent. They were gradual, like fog forming in low valleys rather than on high mountain peaks. A familiar everyday example is rainwater on pavement. When water falls on a flat surface, it spreads equally at first. Over time, tiny imperfections cause water to settle in specific low points. Puddles form not because of intention, but because of gravity responding to slight differences in height. In the same way, the Milky Way formed along invisible density slopes written into the early universe. Historically, astronomers compared maps of the background radiation with large-scale galaxy surveys. They found that the cosmic web of galaxies followed patterns predicted by those early temperature differences. The Milky Way exists as part of that web, not as an isolated accident. The structure of the Milky Way itself reflects this slow shaping process. It has spiral arms where matter gathered more densely. It has a central bulge where gravitational forces were strongest. These features are not random decorations. They are the result of long-term gravitational flow guided by invisible initial conditions. This connects natural law to cosmic architecture. The law is gravity. The structure is the density seeds left in the early universe. The scale is measured in hundreds of thousands of light years of galactic formation. The Milky Way is personal in scale because it contains the Earth and the Sunday. It feels It can only be revealed by sensitive instruments that detect differences too subtle to feel. Yet that invisible structure determined where galaxies would appear, including the one that would later become home to human civilization. The galaxy is not floating in a truly random position. It rests along ancient gravitational pathways carved by the earliest conditions of the universe, preserved in a faint thermal background that still fills all of space today. The formation of planets did not begin when stars first ignited. The groundwork was prepared much earlier by subtle conditions left inside the structure of the young universe. Those conditions were influenced by the background radiation that quietly shaped how matter gathered and cooled over time. The structure behind this process begins with cooling and clumping. In the early universe, gas was spread almost evenly. Tiny differences in temperature and density allowed some regions to cool slightly faster than others. Cooler gas loses energy and becomes easier to pull together by gravity. This gradual cooling created preferred zones where matter could gather more effectively. Natural physics explains this through pressure and attraction. Hot gas resists compression. Cold gas collapses more easily. The ancient background radiation marked areas where this process started earlier and more efficiently. Over long periods, these regions collected more hydrogen, helium, and dust. A simple, everyday example can be seen in steam rising from hot water in a warm kitchen. Steam rises and spreads. In a cooler room, it condenses more quickly and forms water droplets on glass or metal surfaces. The droplets do not form randomly. They appear where temperature and surface conditions allow it. In a similar way, planetary material condensed where cosmic conditions quietly encouraged it. Historically, astronomers traced this chain by studying both the cosmic background and modern planetary systems. Regions of the universe that developed stable galaxies earlier were also the regions that produced multiple generations of stars. Those stars created heavy elements such as carbon, oxygen, silicon, and iron. These elements later became the building materials of planets. This process connects structure, natural law, and scale. The structure was the slight unevenness left in the early universe. The natural law was the way gases cool, clump, and collapse under gravity. The scale extended from microscopic dust grains to planetary systems millions of kilometers across. Planets do not appear directly from the background radiation. They appear indirectly because that radiation influenced where matter cooled, where stars formed, and where heavy elements were created. Each step depended on the previous one. Earth itself exists because these long-term processes remain stable. The sun formed in a region rich with heavy elements created by earlier stars. That region exists because initial density patterns were written into space long before stars were born. On a cosmic scale, the possibility of solid worlds depended not on sudden miracles, but on extremely gentle guidance that began with faint thermal variations in the earliest light of the universe. The background radiation acted as a quiet organizer, preparing the universe for complexity long before the first planet took shape. Modern human technology often listens to space by accident, not by intention. When radios, satellites, and sensitive instruments are turned on, they do not only pick up stations and signals created by people. They also receive a quiet background that was never designed for communication, yet is always present. The structure of this phenomenon lies in sensitivity. Modern receivers are built to detect extremely weak electromagnetic waves. As technology improved, instruments became capable of detecting signals far below the level of everyday noise. This made it possible to hear not only nearby transmitters, but the faint microwave background that fills the universe. Natural physics explains this through the behavior of antennas. An antenna does not choose what it hears. It simply responds to waves that strike it. If the wave has the right wavelength and strength, the antenna produces a signal. The background radiation meets these conditions, so it enters human-made systems without invitation. A clear everyday example can be found when tuning an old television or radio to an empty channel. The screen shows dancing static. The speakers produce a soft hiss. That noise feels random. In reality, a small part of it comes from cosmic background radiation. It is not broadcast by a company. It is not created by machines. It is part of the universe itself, being translated into electrical patterns. Historically, engineers first noticed this effect while trying to eliminate noise. They assumed every unwanted sound had a technical cause. Over time, they discovered that no amount of cleaning, shielding, or redesign could remove a certain portion of the static. That remaining noise had a cosmic origin. This connection ties structure and civilization together. The structure is the ancient radiation filling space. The natural law is the passive behavior of antennas. The human layer is technology designed for communication and observation that unintentionally becomes a listener to the universe. Telecommunications satellites experience the same phenomenon. They must filter out the background radiation to focus on human-made signals. Weather radars, space telescopes, and GPS systems all encounter this ancient noise and must account for it when processing data. The background does not care about human invention. It does not adjust to our devices. It simply passes through, and sensitive systems react. This creates a quiet bridge between cosmic history and modern civilization that exists without awareness. On the scale of human life, this effect feels meaningless. On the scale of science and understanding, it represents a constant reminder that modern civilization operates inside a much older physical environment. Devices built for daily communication quietly acknowledge the presence of the oldest light in the universe every time they are turned on. The cosmic background signal is not permanent in a human sense, but it is extremely long-lived. Its future depends entirely on how the universe continues to expand. The structure of this process is controlled by expansion, cooling, and the gradual loss of energy over unimaginable timescales. As the universe expands, space itself stretches. Light and radiation traveling through that space are stretched as well. This stretching makes the waves longer and weaker over time. Longer waves carry less energy and become harder to detect. This is not a sudden disappearance. It is a slow fading. Natural physics explains this through energy conservation and redshift. Redshift is the process where expanding space increases the wavelength of light. A strong, energetic signal can slowly turn into a faint, low-energy background. The signal does not vanish. It becomes quieter than instruments can detect. A simple, everyday example exists in spreading perfume in a room. At first, the smell is strong near the source. As time passes, the scent spreads through the entire room. Eventually, it becomes so faint that it cannot be noticed, even though it still exists in trace amounts. Historically, scientists predicted this fate using mathematical models of cosmic expansion. Observations of distant galaxies show that expansion is not slowing down, it is accelerating. This means the stretching of space is becoming stronger over time, making the fading of the background signal inevitable. This phenomenon connects structure, natural law, and cosmic future. The structure is the fabric of space-time. The natural law is the stretching of wavelengths. The scale stretches from the present moment to trillions of years into the future. In the far future, the signal will still exist, but no living instrument may be able to measure it. It will not be destroyed. It will be diluted. The fading is not a loss of memory by the universe. It is a quiet retreat into silence due to expansion. The signal that once marked the early universe will become a nearly undetectable whisper, not because it ended, but because space itself grew too large to hold its strength. After billions of years, the universe has not gone silent. It continues to carry the same faint background radiation that was released when space first became transparent. This endurance is not based on strength. It is based on persistence through expansion and time. The structure of this survival lies in the absence of friction. In everyday life, motion eventually stops because of resistance. Air slows moving objects. Water resists movement. On Earth, energy is constantly lost to heat. In deep space, there is almost no resistance. Once radiation begins to travel, there is little to stop it. Natural physics explains this through the nature of electromagnetic waves. These waves do not require a material medium. They do not wear out. They do not decay from travel alone. They only change as the universe expands and stretches their wavelength. This allows a very old signal to remain present for extraordinary lengths of time. An everyday comparison can be found in the vibration of a tuning fork placed in a vacuum chamber. Without air to slow it, the vibration lasts much longer than it would in open air. In space, the universe acts like an enormous vacuum chamber, allowing radiation to continue its journey almost without interference. Historically, this persistence was confirmed as measurements became more precise. Early instruments detected only a general background. Later, satellites mapped the signal in detail and confirmed its stability. Decade after decade, it remained unchanged in structure, only slowly drifting toward longer wavelengths. This phenomenon connects structure, natural law, and time. The structure is the emptiness of space. The natural law is the behavior of light in a vacuum. The time scale is measured not in years, but in billions of years. Even as stars are born and die, this signal remains beneath them. Even as galaxies collide and reshape, this background stays uniform. It does not carry the violence of later cosmic events. It carries only the quiet memory of the earliest state of the universe. On a human timescale, this persistence is impossible to sense. On a cosmic timescale, it represents a universe that never forgets its beginning, not through memory, but through the uninterrupted travel of light. The whisper has continued, not because it is loud, but because nothing exists to force it to stop. The oldest light in the universe does not describe destruction directly, but it carries information about how everything will eventually change. Its behavior allows scientists to infer long-term trends in cosmic energy, temperature, and structure. These inferences reveal not chaos, but quiet transformation. The structure behind this understanding begins with entropy, which means the gradual spreading and evening out of energy. In physics, systems naturally move toward balance. Hot and cold differences fade. Dense regions spread. Energetic states become calm. The background radiation is evidence that this process has been happening since the earliest times. Natural physics explains this through thermodynamics. Heat always flows from warmer regions to cooler regions. Concentrated energy spreads outward. Over enough time, everything tends toward uniformity. The cosmic background is already close to that uniform state, colder and weaker than almost any other known source of energy. A simple everyday comparison exists in a freshly poured hot bath. At first, the water near the faucet is warmer. Over time, the temperature becomes even throughout the entire tub. The surface becomes calm. The water does not disappear. It becomes stable and uniform. The universe follows a similar trend, not in water, but in energy distribution. Historically, cosmologists use this radiation as a baseline for predicting the long-term future of everything. By measuring how fast the universe expands and how the background cools, they could estimate how stars will fade, how galaxies will grow dim, and how energy will slowly spread thinner across space. This connects structure, law, and scale. The structure is the near uniform thermal field of the background. The law is entropy and energy diffusion. The scale extends across trillions of years and distances beyond direct observation. The signal suggests that dramatic endings are unlikely. Instead, futures are defined by slow cooling, fading light, and diminishing contrast. The end is not a violent event. It is a gradual quieting of difference between energy and emptiness. This foregrounds a universe that does not collapse suddenly, but relaxes infinitely slowly. The oldest light does not predict a final explosion. It suggests a long, silent thinning of structure. By studying this ancient signal, science does not see a sharp ending. It sees a tendency toward calmness so complete that structures lose definition. The light that once marked the hottest state becomes the guide for understanding the most distant and quiet future imaginable. The idea that the universe retains a record of its own beginning is not based on memory or intention. It is based on physical processes that preserve information without awareness. The background radiation acts as this record, not through thought, but through the consistent behavior of energy. The structure of this concept lies in imprinting. When the early universe cooled enough for light to move freely, the conditions of that moment were locked into the radiation. Tiny differences in temperature, density, and motion became permanent patterns carried by the light itself. These patterns were not written later. They were embedded at the moment of release. Natural physics explains this through conservation. Energy cannot be destroyed easily. It can change form, it can spread out, but it persists. The background radiation is a physical artifact of that persistence. It exists because the universe could not erase what it once was at that stage. A simple everyday example exists in wet cement. When a footprint is made in soft cement, the shape remains after the cement hardens. The cement does not remember. It simply retains the structure created at an earlier moment. The cosmic background works in a similar way. The universe does not remember in a human sense. It simply retains physical traces of its earliest state. Historically, this idea became stronger as measurement techniques improved. Early data showed only a uniform glow. Later missions revealed fine details that mapped the early density differences of the universe. With each improvement, the idea of a preserved cosmic imprint became more concrete. This phenomenon connects structure, law, and scale. The structure is the fixed pattern of ancient radiation. The law is the conservation of energy and information in physical systems. The scale extends from the first few 100,000 years after the birth of the universe to the present moment. The background does not think, it does not decide. It simply continues to exist in the same form, gradually cooling and stretching as space expands. The patterns it carries remain aligned with the conditions that existed when atoms first formed. Every galaxy, star, and planet formed later. All of them exist on top of this older layer of reality. The background is older than gravity-driven structures. It is older than darkness between stars. It is older than any object that can be directly seen. On a cosmic scale, this gives the appearance of memory without consciousness. The universe does not recall events. It preserves the physical consequences of those events. The background radiation is not a story. It is a fossil. Through this fossilized light, the universe carries a permanent record of its earliest state, not as memory, but as an unbroken chain of physical cause and effect. This signal is older than every form of life, older than stars and older than galaxies. Yet its most remarkable property is not just age. Its true significance lies in how long it will continue to exist after everything familiar has changed. The structure behind this endurance is based on the future behavior of space. As the universe expands, distances between galaxies grow larger. Matter becomes more separated. Stars eventually exhaust their fuel and stop shining. Even black holes slowly lose mass over extreme timescales. Through all of this, the background radiation continues to move, stretch, and exist. Natural physics explains this through stability. Electromagnetic radiation does not rot, decay, or tire. It only changes wavelength as space expands. This means that even when stars no longer produce light and galaxies no longer shine, this background will still remain as a faint thermal presence throughout the universe. A simple, everyday comparison can be found in a slowly fading photographic print. Over many years, colors wash out and contrast disappears. The image does not vanish instantly. It becomes pale, almost invisible, but it still exists as a trace of what was once clear and bright. The cosmic background follows a similar pattern, slowly becoming weaker but not disappearing completely. Historically, scientists realized this by combining observations of expansion with thermodynamic predictions. They understood that no known process in the universe would completely remove this radiation. It would simply continue to cool and stretch indefinitely. This connects structure, law, and scale. The structure is radiation woven into space itself. The law is the conservation of energy and the stretching of wavelengths. The scale reaches beyond galaxies, beyond stars, and beyond the lifetimes of most known cosmic objects. In the far future, intelligent life may not exist to detect it. Instruments may not survive. Civilizations may vanish. Still, this signal will persist as part of the background fabric of reality. It will not carry messages in words. It will not announce its presence. It will simply continue. This makes it a form of silent continuity that does not belong to any species or moment in history. It belongs to the structure of the universe itself. Long after human memory and records are gone, this radiation will remain as a quiet, physical trace of the universe's earliest state. It will outlive planets, stars, and even galaxies, not by force or resistance, but by the simple fact that nothing exists in nature that can fully erase it. Thank you for listening.